Good afternoon. I think we're back from break, so if everyone would like to take a seat, we would appreciate it. Thank you. Good afternoon. I am Paula Manning, and I had the honor of serving as the SAIA's president from 2016 to 2018. I am pleased to present our final session of the convention, which celebrates excellence, innovation, and professionalism within the scaffold and access industry. This is a program that began during my presidency and remains near and dear to me. Today's presenters represent award-winning projects that demonstrate innovation, craftsmanship, problem-solving, collaboration, safety, and exceptional execution. Their work highlights the remarkable capabilities of our members and the important role our industry plays in completing complex and challenging projects. Please join me in welcoming Mark Palmatier, Michael Klein, David Johnson, and Brian Andrews.
No, it's Mark.
Am I first?
Mark's first.
I don't know. That's my
Oh,
name.
no. Klein's up.
That's my name. All right, cool. We'll go ahead and do mine first and foremost. All right. You're up first.
All right. Hello, everybody. I am Mike Klein. I'm with D.H. Glaveness. Well, there goes my backup plan. And so the project that we did, it was for the Innovation Award. It was out at the Coors Tech building in Golden, Colorado. I was really hoping, since it was for Coors beer, I could bring in a black Trans Am and have my buddy Smokey with me. But best I can do, and I will show these off, are my black Trans Am socks. These are my lucky socks. So westbound and down. Here we go. So a brief background. So this is one of the original Coors buildings out in Golden, Colorado. They actually did a lot more than just make beer, especially during Prohibition. They had to do ceramics and a lot of industrial materials, things like that. So this is what the building originally looked like. And what the Coors family wanted to do is they were tearing down the building and turning it into a mixed-use kind of parking garage, residential, retail, that kind of thing. But they really wanted to preserve the existing exterior wall. It was kind of one of the first buildings on the site, and they really just liked the way that it looked. So they kind of tasked us with trying to maintain that as they did all their demolition operations. So this is a joint collaboration between us and JKS Industries. JKS Industries is a demolition contractor based out of Colorado, and they mainly do a lot of bridge demolition work, is kind of how we got to know them originally. Now they're doing a lot more work out at Coors with demolition plans, but this was a pretty big one that kind of carried a lot of risk with it just because of the historic nature of the building. But working with them for a number of years, they trusted us, and we actually had quite a bit of fun doing it. So here is the main thing. What was the challenge? In Golden, Colorado, there are essentially two roads that run from the north side of Golden, which is where all the houses are, to the main part of Golden, which is where the downtown, the Colorado School of Mines, and the actual Coors Brewery and the whole Coors complex is located. One of those streets is Ford Street, and Ford is where they were doing all the demolition. The building kind of off to the left next to the green line is what had to come down. So the biggest part is, again, it's a historic building. Coors really wanted to keep the look of it. You can't damage any brick. Everything has to maintain in place. They don't want anything coming out. They don't want it broken or anything like that as they're doing their demolition operations, so the whole thing has to stay in place. It's also got to withstand all types of Colorado weather, and in Colorado, weather changes very frequently, so we have to kind of account for that, especially the wind in Golden. The green line is a sidewalk. And again, this is kind of the main area or the main way that people that live on the north side of Highway 58 get down into Golden is they walk along the sidewalk. Sometimes, depending on how much they've had, they might stumble back to their house. But we had to maintain that sidewalk open at all time. It's also a 2-lane road, so we can't really have anything that encroaches out into the road. We also can't brace to the inside of the wall because that would have been way too easy because they have too many other operations going on inside there. Even if it was just demolition, we probably could have done something to account for that, but they had too many other things with constructing the new building, so we couldn't have anything on the inside. And again, you can't go out into the roadway. So here is basically how the project looks. You can see it's just what I would consider kind of a simple brick wall with a Coors name up at the top of it, but they really, really wanted to keep it. So again, it is kind of a narrow 2-lane road, and then you have the sidewalk on the left side that's adjacent to the building that had to stay open at all times. They couldn't close that down, otherwise it was going to be a main issue. So how it all started for us is as JKS was getting ready to do some of the demolition, they started taking out some of the slab on grade and said, uh-oh, we have no idea what this is. It actually turned out to be large cobblestone foundations. Wasn't concrete or anything like that. It was big rocks, and nobody really knew what to do. So they called us up to say, hey, how do we at least kind of get this thing stabilized and make sure that it's not going to come down as we start pulling down the rest of the building with it. So that's really what kind of kicked off this whole project for us, is to look at the foundation, and then it kind of became, what do we do with this wall? At one point, one of the ideas was actually cut the wall into sections, truck it off-site, bring it back to the site, and put it back up in sections almost like precast. We decided that was not a good idea, so we went with bracing. Again, the inside of the wall, because of this cobblestone, needed to be strengthened. They were going to add grade beams and additional foundation elements after the fact. So again, we couldn't have anything on the inside to get in their way. So the demolition, the fun part. JKS, again, they do bridge demolitions. They like to be surgical. It's essentially just giant excavators with buckets and shears and hammers and things like that. So all of the demolition was performed from the inside of the building using all these large machines. There was nothing small out there whatsoever. Everything was done by very skilled operators using the large excavators on the inside. The way they did the building is the reverse of how they built it. So they demoed it from the top down. They didn't want to try to pull columns from the bottom and kind of let it come down. They wanted to basically take it apart piece by piece from how it was originally built. And part of that also mentioned they had to pull out a lot of the main support beams that ran into the pockets of the brick wall. So that was very, very careful to pull it to make sure they didn't pull the brick with it, because, did I mention, you can't disturb the brick wall whatsoever. So the way we approached this is we started by making sure the wall was actually secured. What we did is, with a 100-year-old brick building, we essentially designed a steel exoskeleton to go on the outside of the wall. We used steel beams, just I-beams vertically, and then for the time being, we had timber members with coil rod going through there to essentially squeeze the steel members on the outside and inside of the wall, creating a bit of an exoskeleton. Part of it too, they didn't want any penetrations, no kind of anchors into the wall, because again, they didn't want to have to go back and try to fix something when they were done. So the nice thing about this building, there's lots of windows, lots of door openings. So we were able to get quite a bit of coil rod to go through without having to actually drill through the existing wall. So again, more just, we had all these beams out there, and then this is eventually what it looked like. So what we started with was kind of the picture on the left. While the building was still standing, they cut open holes in the roof, dropped down these vertical steel beams, kind of held them in place with timber and some coil rod, and then you can see the picture on the right is everything is demoed out, and we have horizontal whalers going through there as well. Everything is connected, so it's all actually functioning as one giant piece of wall without the rest of the building around it. So here is what we had to do to ensure that this thing was braced. We couldn't really do tilt-up braces on the outside because they were going to be too long. Also, we wanted to try to brace multiple connection points on the wall going up. We didn't, because it was a multi-story building on the inside, we didn't want to just have one brace that could be up at the top, because then you start worrying about concentrating the load. So what we decided to do is essentially use system scaffold, and we created another almost mock building on the outside that we could start attaching everything to. So the nice thing about it, the sidewalk was extra wide. I think it was about 10 or 11 feet wide, so it worked out really, really well for us to get everything in there. I will say with the final layout, everything was pushed basically right to the edge of the curb, which is where they had that vehicle barrier. Again, this had to be open to the public, so it also incorporated not only the bracing, but also overhead protection for all of the people walking through there. Those are also some signs on the side that are trying to discourage people from climbing it, but who knows? We couldn't install any type of substantial anchors into the sidewalk. Again, they wanted to do as minimal kind of repair work as possible when it was done. So instead, what we used was stacked dead men concrete blocks. So on the inside, there's 3 blocks on each side. They brought them in on a truck, unloaded them with a forklift out in the road, and then basically sent the truck on its way, again, to try to minimize any kind of street closures. So everything had to be done very, very quickly and set into place. And then the nice thing is that even though they had this K-rail on the outside, right up against the gutter of the curb, all these dead men blocks also acted as a vehicle barrier just in case somebody got a little sideways, and they didn't want somebody running into the scaffolding to tear it all down because it's also still actively bracing the wall and didn't want to have all of it go with it. So it kind of ended up looking like a giant jungle gym of not only scaffold parts and pieces, but a lot of straps. So the other thing too is they used the straps to hold down all of the dead man blocks, because we kind of ran some numbers and found that having all of that concrete weight at the bottom of these things was probably going to do quite a bit of damage to the runners. So we said, okay, we'll set them on the ground and we'll just run straps around everything, run them to the tops of the legs, so that way all that load is still concentrated into the legs and the runners are really just acting to kind of space everything out. On the picture on the right, again, it's a little bit close-up shot. When all was said and done, we had 2 sets of coil rod, again, going through all the window openings to create this exoskeleton of everything squeezed together. And then essentially we took beam clamps, so system scaffold beam clamps, ran it from those beams back to the legs of the scaffold, and now everything was all tied together. So again, weather. This is actually one of my favorite shots of this project. I have kind of a thing with construction sites when it snows. It's just everything seems so peaceful before all hell breaks loose. So this is kind of a nice way to start the day. Again, with Golden, Colorado, it's at the base of the mountains in the foothills. It is in a special wind region, so kind of almost that one street, Ford Street, has 150 mile an hour design wind speed to it. Go kind of like 1 block over, it could be 160, but that's what we were dealing with for the time being. There were a number of days that we had sustained winds over 70 miles an hour, kind of for the whole day long. We'd get gusts over 100. So yeah, it's that's what happens in Golden, that part of the town, especially in the fall and winter time, is you do get a lot of wind. So what the contractor wanted to do, again, to make sure we can't disturb the brick, is they went out and surveyed before the weather got really bad. Took a number of shots, before and after wind events, and everything we were told is that nothing ever moved. Everything kind of stayed right in place. They didn't lose any bricks, didn't create any new cracking. So the scaffolding provided plenty of rigidity to not allow that wall to flex. So again, dealing with a lot of the snow and the cold. Probably by the time that afternoon, a few hours later, it was sunny, the snow was all gone, and people were walking around in a t-shirt. So again, on the inside, once they removed the existing building, they were going to do like an underground parking garage in there. So they got a caisson drill rig that you can see that in kind of the background. And they were adding in all these soldier piles. They were going to do, I think, about a 20-foot deep mass excavation. So again, that's also why we couldn't have anything on the inside, because while they were doing that, all of their shoring had to be close to the existing wall because they couldn't lose the footprint of the inside space. And then we also had the picture on the right, more contractors coming in, doweling into the existing foundation that they had to dig down a little bit further underneath where the slab on grade was. To install additional grade beams and things like that. So again, a lot of things going on, but you can see all the exoskeletons stayed up out of everybody's way, didn't really encroach on anything. And so when all was said and done, this is John Heiser. He's our engineer that designed this whole thing. This was a great picture for me because he was just so proud of this. I had to go out there a number of times and just tell him, how happy everybody was with the project. But you can see at this point, there's no more building. There's just a wall. So this is the final configuration at the south end. Because of the way the road tapered down and sloped down, It was about 30 feet tall, give or take, at that one end, not with just with both the brick and also the concrete foundation. So, we realized that if we tried to do tilt-up braces, again, they'd be out in the middle of the road. So by using system scaffold, we can kind of just keep building all on top of it itself and brace it really well. And the other nice thing is we were able to allow other trades to get up on the scaffold and do the work that they needed to do. Again, because they didn't want to shut down the sidewalk to allow boom lifts and things like that. Well, now we still have an overhead protection design, and we can also have other trades working on top of there. The main thing from our end on a design standpoint is we just had to say, okay, because this is still rated for wind loads, if you're going to have people up there, it's going to add to the load of the scaffold. So, don't put anybody up there over X amount of miles per hour and say, 1 or 2 people per bay. So we kind of tried to give them a bunch of different options of how to use this, so that way they wouldn't have to tear it down, bring in other equipment. We tried to make it really beneficial for the project as a whole. The sidewalk was never closed. So even during active demolition operations, it was kind of hairy sometimes to see the giant excavators on the inside pulling out timber and everything like that. But the sidewalk, if you were on the sidewalk side, you wouldn't have known the difference. So everything still stayed open. People were able to ride their bikes up and down the sidewalk. And so it was one of the best things for it. And all the equipment, none of it was really custom made. Everything was all just prefabricated system scaffold components. The steel beams were basically what the contractor told us, this is what size we have. Okay, we will make it work. So that way if they ever ran out of something, it was easy to get more of it, and made it real simple for them to erect it, dismantle it, and then have a nice beautiful wall when it was done. So that's our wonderful coolers project. We're very proud of it. It does look really nice, especially they kind of went through and I think acid washed or cleaned the walls or something. So now with new building on the inside, it looks substantial. Any questions? All right.
How's that? All right. Good afternoon. My name is Mark Palmatier. I'm an engineer at DH Charles Engineering. And for the Commercial Collaborative Award, I'm presenting on the Tomochichi Federal Building. So a little overview on the project and the building itself. The Tomochichi Federal Building is located in Savannah, Georgia, in the historic district of Savannah, Georgia. It was originally constructed in 1890. And it was originally designed as the nicest post office that you've ever seen. But eventually they converted it over to a courthouse, and it's operated in that capacity for over 100 years. The facade consists of granite stone with symmetrical columns, and it's an excellent example of the Renaissance revival style that was popular in the 1800s. It's for this reason that it was added to the National Registry of Historic Places and deemed worthy of preservation. And in 2022, it underwent a full rehabilitation. So work went on throughout the building, but our main focus was on the tower structure. The work on the tower consisted of a full restoration of the facade completely around the tower and all the way up to the slate stone roof, which is 140 feet above the sidewalk level. In addition to the exterior work, new reinforcing steel was to be installed inside the body of the tower, meant that steel beams had to be brought up from street level, staged, prepped, and then brought into the tower. Right out of the gate, there were a lot of challenges with this project. The first big one was we are located in the heart of a Civil War era downtown, meaning very tight streets, no room, historic buildings all around, so even figuring out where we were going to put scaffold was difficult, much less providing any sort of lay down or work yard. The second big thing was that this building was like old, meaning we weren't sure what it could support, what kind of capacity we could get out of it, and so wondering whether we could even interact with the structure at all was a big question. The last big thing that we really need to do was make sure we got everybody on the same page. Not only the people we were designing with, but also the general contractor, and coordinating closely with the owner's reps and the engineer of record on the building to make sure we all understood what we were expecting out of the scaffold, what kind of design parameters we needed to meet, and making sure we had a smooth design process all the way through. So a job of this complexity would just be absolutely impossible without clear communication and good collaboration. And so it's for this reason that we were really happy that we teamed up with the Tradesman Group and Universal Manufacturing. They were the core design team on this project. The Tradesman Group was the restoration specialist and the ultimate end user of the scaffold. So we were able to talk directly with them, understand exactly what they needed out of the scaffold, and design for the parameters that they needed. Universal was critical in ironing out the initial design work. They worked closely with tradesmen, put together the conceptual designs that we were then able to take, fine-tune, and put into the final working plans. So after a few months of working with the core group, as well as coordinating with the GC, the owner's reps, this was the final scaffold design. So ultimately, it's a comprehensive system that provided both the worker access to the tower as well as a work deck for the work. But really broken down, it's actually two designs that have been structurally integrated to be as efficient as possible. Most simply, it can be broken into the tower scaffold and then the platform structure. So the tower scaffold used the platform framing as a foundation and then extended up 70 feet from there to reach the top of the 140-foot tall tower. It was designed to wrap completely around the tower, be fully enclosed, and then utilize the tower structure as the lateral support system. Because it was fully enclosed, we were required to design for a 90-mile-an-hour wind speed in case anything happened. That is analogous with a Category 1 hurricane. That is going to come up later. So as the scaffold increased in height, it stepped in to allow workers close in access to do the fine, detailed restoration work they needed to do. It was designed for a typical light-duty worker live load, but also was designed for a 500-pound material load in the event they had to fully remove a piece of stone and replace it. Now, on the interior courtyard of the courthouse, it was slated for full demolition and even some excavation, meaning we could not put any scaffold down on the inside. So what we opted to do was suspend the scaffold from the platform framing that cantilevered out beyond the face of the building. We did this utilizing custom fabricated brackets put together by Universal. Because the overall project was restorative in nature, having as little impact on the structure as possible was key. And this was especially important with the scaffold ties. So what we did is we put together a computer model of the scaffold, induced wind loading so that we could accurately determine how much load would concentrate at each tie. From there, we utilized compression bump ties where we could, so that we would not have to drill or do any sort of rigid tie to the structure. And then where we did need a rigid push-pull connection, we designed a tie that would have maximized strength but minimize how much impact was on the building and how much repair they would need to do on the back end. So when it came to the platform design, the platform was going to work as not only the foundation for the access scaffold, but also the backbone for the work deck, consisting of 68-foot long steel beams that were designed to be spliced together in the field so they could actually transport these on site. It actually cantilevered out beyond the face of the building on the back side so we could hang the scaffold, and then provided for a 34.5 by 43-foot work deck on the front side. The work deck was designed for a 50 PSF workload rating, as well as a handful of concentrated high load scenarios as they would move material up. On the front face of the platform, it actually extended 15 feet beyond the edge of the building. We did that utilizing 24-inch tall steel beams that would be supported by Universal Manufacturing's heavy-duty columns. This allowed us to extend the platform out to the face or at the edge of the sidewalk. This way, they could bring trucks in loaded with steel, park them right on the street, and offload directly to the platform utilizing a hoist. So that way, there was no secondary laydown yard necessary. They didn't need to bring in another crane. It sped up the construction process a lot. So once we got into the platform design, it became pretty apparent that there's no way to give them the space they needed and the load rating they needed without interacting with the structure in some way. So once we got the design parameters for the platform, we took a look, saw where we could and could not support off the structure, and then dove deep into kind of how that interaction would look. And ultimately, we decided to support the platform off the actual existing structure in 12 different locations. 10 of them were a column type support, while 2 of them were a pocket type bearing point support. So the column type supports were designed to go through the roof structure and tie in directly to the masonry walls below. These columns did not just bear on it, but they actually bolted in and locked in. That allows us to use them for both vertical load as well as resisting lateral load. At the tower structure where that was not possible, pockets were actually opened up in the tower wall, and then we were able to slide the beams in and just bear directly on the wall itself. So once we figured out how we were going to sit on the building, we kind of had to determine whether we actually could sit on the building. So D.H. Charles was tasked with checking the adequacy of the actual courthouse to support these vertical loads. This was not easy. We had to not only dig through 1800s era as-built plans to figure out what this thing was made out of, but we actually had engineers go on site, walk the entire building, following the platform load paths to make sure we had a clear understanding of the current status of this 130-year-old building. Where there were no clear specifications on material strengths or anything on the plans, we had to actually do research and find references for what a typical strength for that material was. And then using our engineering judgment, worked with those capacities to check the structure. One kind of fun fact about this building is, if you look here, that is a cross-section of the typical floor. They made these floors out of terracotta tiles that were then stacked into a compression arch. They did that because when this building was constructed, reinforced concrete didn't really exist yet. So this was how they actually created floors between steel beams. It's also the reason why we didn't interact with any of the floors at all and went straight to the walls, because I'm not messing with that at all. So the last little tidbit about this project I'll let you guys know is, if you remember at the beginning, I referenced wind speeds and how we were required to design for basically a Category 1 hurricane. This is Hurricane Idalia. This formed in the Gulf and made landfall with the Florida Gulf Coast as a Category 4. That puts wind speeds between 130 and 150 miles an hour. The path of the hurricane went up through Florida, into Georgia, and right through Savannah. So for the 24 hours that it was passing through Savannah, I did not get a lot done. I just refreshed the Weather Channel page a lot. But when the storm passed, they did a full review of the platform. It worked just as we designed, and I could not be prouder of either the design or the team that helped put it together. So at this point, I'd actually really love if Tony and Chris came up with Universal Manufacturing, because is a collaborative award, and we just couldn't do it without him.
Nice presentation.
So that's pretty much everything. If there are any questions, we'd love to take them. Very cool. Thank you very much.
Good afternoon. I'm David Johnson, and with Skyline Scaffold, I'm going to talk to you about our PG&E Tower 320 demolition project, which was the 2025 Industrial Collaborative Award winner. We're collaborating with D.H. Charles, who's our engineer for most everything we do, and we really appreciate them doing exactly what they do for us every day. Here's the call we got. So, first of all, Skyline Scaffold is an approved contractor for Pacific Gas and Electric, and we do a lot of work with utilities, and I'm sure most folks do, but PG&E has got a pretty rough indoctrination program. It takes a lot of training and a lot of time, a lot of, we got to know how to not run over desert tortoises. It's a very complex set of training. But we had lots of hurdles and trainings and be completed before they got on site. And those being completed allowed us to be able to respond very quickly. Silverado Contractors was not really well known to us, but they were well known to PG&E, and so are they. They asked us if we could show up because basically the demolition guys needed some form of platform, and they needed it in 10 days. So time from call to build was 10 days, which means we needed to job walk, get drawings, engineering done, a logistical plan that worked for the ecological site that we were in. And I'll get deeper into that conversation in a moment. And I gotta say, without our relationship with D.H. Charles, my estimator, Joey, called, walked in the office, covered in marsh mud, which I'm really not sure what's in there, and called Robin Coe at D.H. Charles, and they were in immediately. Here's the location. It's in Antioch, California, and this is an ecological wetlands project that is called West Island. There are several PG&E transmission towers that exist on West Island, and this one had been decommissioned and was ready to be torn down. D.H. Charles and our team came up with a plan for towers on both sides of the platform to allow for the placement of demolition charges so that we would be able to do a controlled demolition on taking this tower down. For that, we knew we were going to be tight. We knew we were going to be time, so we brought in our heavy hitter crew. This is just the most beast-like human beings you will ever meet. They are big and burly, and when something needs to be absolutely destroyed overnight, that's the guys we send. Material delivery involved putting everything on a barge. So we went to San Francisco to Pier 97, had all of our scaffold put it on the crane and then put it on the barge. When it got to the island, we actually had an excavator team that put all of our scaffold on some big crane mats that they had brought in to keep the everything from sinking in, and then we were able to get to work. The erection process took 2 days. A lot of just careful planning and making sure that we had everything exactly where the demo team wanted it. A lot of conversations about exactly where the placement was going to be. The demo team came in, and while we were on site, on standby mode, waiting for them to finish up what they did. They placed 9 pounds of demolition, which is not a whole lot in the scope of explosives. After that, we had 4 hours to tear everything off because we had a window at 4 p.m. that had to be met, or we would have to reset for the next day and remove all the demolition charges. So when we talk about demolition, I was a combat engineer in the Army for 20 years, and this is what most of us see. Now that there is a mine clearing line charge, that is 1,600 pounds of C4 that's being let off so that we can clear a 100-yard section of battlefield from mines and everything else that might be in there. But this is what we really got to see. So here you can see the tower as it stands, the barges that we brought everything in on. This is our team in, I think this is actually in dismantle mode. All those plywood boxes you see on all those places, that's the demolition charges that were placed. And since this was such a sensitive ecological area, we couldn't bring in, large trains and stuff like that. And this is what she looks like. Fell perfectly into the prepared area that we expected it to be in. You can see this, all this matting and netting that they put out there, and that is where they had to remove by hand all the cord grass and other ecological stuff. And here's the result. This meant that the team from Silverado Demolition could go in with some of their smaller excavators, cut this thing up, and remove it off to the barge. In the end, I love this project because not only is it just plain cool, we don't get to see demolitions a lot every day, but it really showed our relationship with Charles and our team's ability to respond to a really tight timeline that involved a whole lot of real not normal logistics. And so I really appreciate the team from Charles and my team for what they did to get this thing done. Any questions for me? Thanks a lot.
All right, so we didn't blow stuff up, but we have some pretty cool stuff. I'm Roger Jatan with Scaffolding Solutions. We operate from Maryland to Charleston, South Carolina, and the Mid-Atlantic states, and I'm here to present with Brian Andrews the Collaborative Suspended Project of the Year, and we're going to Mutt and Jeff this presentation, or call it Brian and Roger it. Yep. And share different segments. Let me ask you a question. Have you ever gotten initial call on a project, and you start going through the details and you think, you know, that's simple, straightforward. We got this. Piece of cake. And that's sort of how this job started for us. But like you probably, when you start getting into the details of means and methods and how you're going to do it, all of a sudden you got a real challenge on your hands with some trickery and some creative solutions that you have to have. And when we got the call from MCA Construction to provide elevated worker access on 5 60-foot enclosed glass bridgeways running between 2 elevated sections of the U.S. Holocaust Museum in Washington, D.C., when we started drilling into that, all of a sudden, we needed some help because those bridgeways were above a glass atrium ceiling from the atrium area down below, and there wasn't much of anything to hang on to or build up from. And that's when we called Brian for some help. Brian?
So, yeah, when Roger called up, you know, he had a lot of different issues, if we want to call it. You know, nothing was kind of normal for this project. We had to figure out how we were going to provide a platform to access both the sides of these walkways along with the underway on the underside of it. So that sounds pretty okay. That's easy to do right off the bat. However, these walkways weren't very wide. And so the way that we would normally do that, you just couldn't do. Because you couldn't actually pick up a platform, move it out, lower it down, and then be able to access on the underside. Along with that was the fact that there's a glass atrium underneath. So now all of a sudden we had a lot more issues at hand. We wanted to make sure that nothing could go and fall down below. We had to make sure that how this platform was going to be erected was safe on the original putting it together. So how were we going to do all of these different things? So overall, what we plan to do is build up a platform, a scaffold up top, on top of the walkway, and then have some cantilevers off of that scaffolding to erect the actual platform itself. Pick the platform up slightly, remove those little outriggers off of the platform, lower the platform down, and then create another brand new platform connecting the 2 platforms on either side of the walkway. We've done it before, but not with a glass atrium underneath. And so there's a lot of different things that we had to look at and make sure that everything was tethered, right? Make sure that nothing could actually fall. Make sure that all these plans were kind of correct right at the beginning to make sure that, all right, the distance in between the 2 suspended platforms, now you can actually connect in between with plank and make sure that that doesn't want to try to separate midair. So how do you do all of that different stuff we had to look at to make sure everything was spot on?
Well, in almost everything we do, safety is always a critical and important priority. The museum, which is a record of a very difficult and horrible set of events that happened against a race of people in our past. And recording that and preserving that was really important and why the museum was put there in the first place. So there was an element of reverence and responsibility of our work there, and the museum had to be fully operable and open during the entire project period. And so underneath those bridgeways, and under that glass atrium, an entire population of visitors was taking place all at the same time. And so managing that safety and that risk was especially critical. One of the things that our company does is established a pre-job launch event called Day Zero. And Day Zero is when we gather the critical stakeholders that are going to deliver the work and go through the briefing details of that project, of what we have to accomplish, what the risk factors are, what are the specific means and method steps that we anticipate that we're going to have to do, and more importantly, how we're going to do it. And we spent a really significant amount of time on this job, even though it was only 5 60-foot long by 8-foot wide bridgeways. The risk and the project itself was critical. And we are really proud of what we accomplished with our team there. You got the next one? We completed the work without incident, without a problem. Our customer was able to put as many as 15 workers on those platforms at any one point in time to accelerate their work, to meet their project schedule. The structures had no repair, no painting, no maintenance whatsoever for 30 years from when it was originally built. And so this was a really critical and important project to avoid moisture, egress, leaks, and then to paint the structure to preserve the quality and caliber of the steel, as well as the aesthetics of the visitors looking up through the atrium glass to these bridge walkways. And incidentally, each of those bridge walkways were named after a specific concentration camp.
So why was this really successful? And why was this project really successful? And the main reason, I feel, is the fact that everybody got involved right at the beginning. And so right when Roger and the team realized, okay, we got to talk to B-Access and figure out how we can do this, who needs to get involved, the entire team got together, figured out all the requirements for the project first. Then we went into, all right, what's the solutions for this? How can we solve this issue and gain access to this bridge? So I feel right at the beginning that's the best thing to do, is get all the parties involved right at the beginning time of it. Review the project, review what's required for access, and then we can actually go and deliver a solution. Let's see. Oh, that's you now.
I guess the key takeaway from me and our company is within the association, there are tremendous resources for all of us. The idea of collaborative work together and these project awards is especially meaningful when you go through this and you find a project partner that brings so much knowledge, skill, and capability to the job, and it makes things go so much better for us. And it's happening every day, and it's what's so great about our organization to have these resources here that we can all turn to, rely on, and utilize. And I'm grateful for Ryan and B-Access on this job. Thank you.
Any questions that anybody has? No.
What was spanning under the bridge? What did you use?
There was nothing there. I'm sorry. There.
You had to provide access.
Yes. So,
What was the material under the bridge?
they were repainting the underside.
He wants to know how we did the platform we built.
Okay. So pretty much the true solution was we created two platforms, okay? Two standard suspended platforms with 90-degree corners on each side. Then we had end gates on those right at the beginning. The platforms lowered down, so they were right below the actual underside of the bridge. And then people were on both platforms, and what would happen was you would actually rotate one 2-meter section, side frame, and actually connect it into the side of the 90-degree corner. Do it on the other side. So you were doing actually individual components to create the rectangular platform first. After that was done, then we actually installed the plank boards across to create a full dance floor.
Yeah, we essentially installed a hanging dance floor, elevated platform underneath the walkway.
Yep.
And you had like four motors per side?
4 hoists total. Yep. 2 lines per hoist, so that then everybody was tied off to the platform itself. So all your, your safety on that side of things was kosher,
Yeah, so we wanted to share our simple, little, easy job with you today.
Yeah. Any other questions? Okay. Thank you. Roger.